I am continuing on the theme of how to make solid models which are useful for laying out equipment. I have covered a little bit of about how to make a small electromechanical item. So, typically the simplest thing you can think of is probably the switch. So, if you come to this, you remember this, and then I also told you, if I now make a proper switch and I can make it generic by giving it different colors and so on, and then I can reposition it various places. Now, imagine this requires to be having an enclosure at the back. Now, at this point we definitely require to make fasteners to put it together. So, I have made a generic fastener, and previous lecture, if you remember, I had covered a little about the type of screw heads, the type of various types of other fasteners. I will now just talk about one single item, saying how do I attach two simple sheets and try to make several types of openings in them. The basic sheets are the two sheets put one top of the other, and in the case of usually our enclosures, usually there will be a small lip at the bottom and something overlapping here, and we have fasteners which are fixed there. And these fasteners, which if I remember, I told you, if you couple it along with the drilling detail, a few other issues are involved in it. And why do we need to learn? Because these are the ones that will create surprises, and as a designer, if you are familiar with why this is done, it is very easy for you. So, let me start with one of such things here. So, please look at my this thing here. This is, as I said, it is a very generic fastener. Now, I will hide this. You see here, I have distinctly two objects which I have created. One of these objects is, you see two of them here. So, I will just give a, both of them they represent two things. This one, the right side one, is an actual fastener, meaning there is a small cylindrical part which is the one that passes through something, and on the top there is the head portion of it. And in the previous lecture I have covered saying there are a very large number of these, the heads which can be which can be used. So, intentionally this was made such that it is made in a generic portion. I can remove this head and put something else. So, first time by looking at the catalog, I need to create a cylinder of this specified diameter, and I need to create something which is as per the norms that were given. In the case of our metric, usually if this is the diameter, this will also be nominally about the same diameter. In this case, this is slightly different I have again. And then the most important thing is, in the case of this tapered or countersunk head, the angle in this is very important. Here, in the case of our professional thing, you will come to other important thing. One of the important things being that most drill bits are not 90 degrees, depending on the way the machining operation are done. They vary between 110 to 115 degrees, depending on the basic material and so on. So, if once you specify that this has to be 90 degrees, the process planner will know that all the countersunk they have to make things properly. And one more thing also I have told you about, saying the problem with countersunk is it locates itself almost absolutely. So, having two countersunk fasteners and having two fixed nuts, usually there is no adjustment possible, and even a small variation, typically in the sheet metal it is up to order of 0.2 0.3 mm variation, is likely to create a serious issue. So, in all those cases wherever it is permittable, they will not use a countersunk fastener. However, if you want to use a countersunk fastener, I will show you how the thing is done and all that in another thing. Now, let me get back to, I will now save this, yes, and now go back to this. You see here. Now, if I want to, let us say, fix it somewhere, all I need to do is import that piece, saying there is an import provision here, and see where is it sitting? At this point I can now do various operations like move this both of them out here and orient them properly. See here, we have, I have created something which is at one level quite useful. Let us say it needs to be fixed to another chassis. Now comes the interesting point in this. I will just make it in what you call little faster. It is customary to have the minimum amount of fasteners. So, I keep one here, keep one here. Now comes the small, I will say trick or whatever it is. You will notice that I have two perfect solids, and if you examine the solid again, I will just open it on the other side again. I go here and open this separately. One of the things you will notice is there are two portions in this. You have noticed that this one is a little bigger than the other one, the inside one is a little bigger than the other one. The outside cylinder represents the hole that we need to drill. So, while making this fastener in this case, just to show you, I have just like that I have made something bigger, but we need to make a particular thing depending on the size of hole I have told you. In the case two items have to be located, it is customary for us to make one of the items, one of the fixing holes a little small. So, in the case of M3, customarily 3.2 mm is used, the other is made a little bigger, customer again 3.5 is used. So, in one corner if it fits, making all the dimensions from there will be convenient and usually it fits well. Now comes the whole thing saying, in the case of our manufacturing, can we have so many types of openings that are required? That is where it is a question of what you call your practice. Me being trained under an old Deutsch or German system, I am all for being perfect. I am all for making 3.2 holes in every corner and having 3.5 mm holes elsewhere. But it has been of late, it has been very sort of common that generally they will probably make all 3.5 millimeter holes, and generally something else somewhere else will locate all these things firmly. So, I will just show you this, saying this outer one, this one represents the hole and this one represents the what you call the actual fastener. So, at this point I will close this drawing and open this back. Right now, if you say, if I rotate it on the other side, first thing you will notice it is a it is just a sheet. Now comes the important point. Now what I do is, I take the outermost in the sheet, I have an opening. You have seen here, thrilled, I am thrilled at least, extremely thrilled. Now comes the point, if let us say I had made a nice unit including what I call a bottom cover and all that, this fastener I can just introduce it, do the Boolean operation, and I have the nice set ready for me to get everything ready. Just to make it a little more interesting, I will now see if I can create the I have a line which I expect which sits here. Can you see? Now comes the other thing, how do I, once again we get back to those fits, by which saying when two covers need to fit, how well will they fit? In that case it is a very loose assembly fit, meaning there must be a gap, typically at least excess of 0.5 millimeter allowance is required. This 0.5 millimeter allowance takes care of all the small inaccuracies that are likely to spring in the case of manufacture. So, I have here the old I tried just to make things easy for you to understand. You have seen this, I will delete this. Now, I have this construction line which you see here, I have a chassis which is it strong, and I have all the necessary things defined. You see this? This has been worked back from the front panel, which we have started with saying typically this type of dimensions we require. And this could be the chassis which I am talking about. So, what I do is I weld all these things together and see where it is sitting actually. See, this thing is here. Now, I try to extend it to cover, make a solid out of it. Now, you will notice in this drawing, I have this nice inside cover also ready. You have seen this? I have the inside cover ready in this. So, to continue with the earlier my assertion, if I carefully look at this drawing, I have this has been created using several surfaces. All I need to do is, because of some technicality which I will try to explain to you later, all these surfaces need to be grouped together, moved inside, and one more time we try to operate this Boolean which I was explaining to you earlier. See, now that fastener detail which I tried to create earlier has now been, you see here the hole was drilled earlier. This is where I feel, not about I feel, the reality is that if you use this method of trying to create these various things, it is very much possible for you now to align items and have various types of these features ready for us. Can you see here? Now, I will try to do the same operation which I have done earlier, except inside. You see, this is the outside one which I am interested in. Inside one can be hidden actually. Now, I try to do the same, all the necessary details which were kept below can seen here. I have the inside one, we have a opening here and a little by mistake, a little by intention, I have not converted to a solid the earlier portion. It can be a thicker bar. Why do we need a thicker bar? Coming back to the old system, you may not have access at the back for holding the nut. So, for the purpose of holding the nut there, we can have instead a long strip which is having two taps on both sides. In fact, long tapped strips are available for us which are part of the 19-inch rack system. So, if you can get these long strips which typically can have a minimum of 2 or 3 taps on one side, another 2 or 3 taps on one side, we can insert one of these things at the back and fix the screws. Why this business of fixing the screw, which we once again I will come back here, I will try to for the moment I will just hide all these inside ones or delete it best. See here, now comes the important point saying, can I make a countersunk? Here we have the advantage, why I had made that strip. In case the sheet is very thin and then still you want to need a countersunk, most likely you probably need a small build up at the bottom and have this countersunk on the top. So, I will take it here and see if I can do some method of having a hidden fastener. Easiest, as I have explained to you earlier, it is all very easy for me to make see here at the back of it I attached a small strip and this strip can be part of the chassis which I have told you. And why all this circus, all this I mean what do you call this very complicated construction is to make sure that in the end we have a nice piece like this which has all the countersunk which I am talking to you about. You have seen this now, the bottom piece has the countersunk, so that a top portion of the sheet also got the has the countersunk and it goes inside. Now, let us say this piece and the other thin sheet are somehow attached together. Simplest way is, that is where I said we can have these things which have tapped holes. So, we can make a nut, we can make a long strip nut which is long and narrow like this. So, for the while I will just use this piece, hide all other items and see how well whether we can create a strip nut with this. You have seen this is a long strip. Now, if we can create a spiral or a what do you call a hose thing like that, which has the necessary amount of various details. It is a relatively simple job for us to create a thing like this. I will just see here if I can create a thing like a various types of what do you call spring like objects, various types of torus like objects, various type of pipes. We can make a spiral like thing and subtract it from this. Once we make the spiral like this and subtract it from this, very easy for us to create. So, we have things like this saying, we can make rails, we can make what do you call things like helix, then we can make a helix. See what we have here. So, in another view, it is an object which looks a little like a spring. It is actually a spring like object. All I need to do is make a appropriate thread form, and in general what we have in our what I call thing is simple triangular forms. In this, all I need to do is somewhere here I create a small what do you call number of sides, generally all triangles we know. You have seen? I have managed to create a triangular thing, except a small my indiscretion. I need to rotate it it looks nice. Now, I try to extrude the surface along a curve. See, I have a reasonable looking thing which looks a little like a screw. If I properly orientate it, in this case the inside forms all right, and then in case if I play around with the pitch and all that, this can be used for showing a screw thread, but as you see it is getting very complicated. So, at least once if you spend the time, find out which is the thread profile and on what this thing the screw moves around, it is very much possible for you to create several items together at one point. One of it is part of the fastener is the actual cylindrical portion, and part of the cylindrical portion is the clearance hole. Again, two types of holes are possible, and we also have important thing is the diameter, and then if you go back to that metric this thing, the length of the threaded portion, the unthreaded portion, and the formation of the head on top of it. Also attached to that is this thread form. So, if you once if you create the proper thread form, the proper pitch and all that, all the pitch details and all are available in the corresponding IEC manual. So, quickly I thought I will show you this. Now, you see that it is possible that the thread pitch and these things have to be adjusted carefully. The triangle you make and Sometimes things like a helicoil uses a very different thing. Please look at the other monitor. I will give you a thing called a helicoil here. For soft materials, we end up with this thread inserts. One of the things you notice about this thread insert is it comes with its own threading system, its own full kit it comes here. Magic being in soft materials, suppose let us say you want to do something in aluminum, you can't afford to cut a fine thread in aluminum. So, this particular form has a diamond shape. The outside diamond goes and sits in the opening that you tap using an oversized tap, and once you push it inside, inside forms again very hard threads again, and inside will strictly follow the thread norms which are specified either as in metric or in the case of US we have the unified national, say coarse, fine and extra fine. In the case of we have of course so many other things including Japanese just including ghost from Russia and all that, and the ever present British standards. We have the BSS and the British so many BA threads and all that. For all each end of these items, small accessories like this and the basic fasteners themselves are available. But once depending on your what you call interest, you have to create one fastener with necessary details including a proper type of head, and from there you can play around with make it a cheese head, make it a countersunk head, make it a pan head, make it any other head, and inside the head we have the opening inside. So, commonly we have things like loosely what we call the Phillips head, or they call it I do not know, I have used called cross head, and I am sure there are other names. And one important thing in mechanical engineering, we also have the Posey force. Just like we have Posey force, we also have offset, what do you call this offset Phillips or offset star headed things. They have special purposes. If you create ones, you can use them everywhere, and drawings related to that are freely available, they are open source. So, next time I will try to show you using a basic 3 mm which we commonly use, we can easily make a 2 mm, a 3 mm and then anything else, except that it is very convenient to start with a 6 millimeter fastener. And you know why? While the nominal diameter is 6 millimeters, the pitch comes to exactly 1 millimeter. So, half of it is for 3 mm it will come to 0.5 mm. So, while creating that whatever you have seen here, if I followed that pitch properly and if I followed the nominal diameter and final thing, once if I make the fastener, in fact the fastener can always also come with the thread on top of it. I just need to take two instances of the fastener. One instance is where you want to make the opening and all that, so it can have just a cylindrical portion. One instance where it needs the thread also inside. If I now boolean the thread portion of it with any of the other things, I have a beautiful tapped location, and if I boolean difference the other thing, I can have the opening inside. Advantage of carrying all this is that it is relatively easy for you to make things. Now, one last time before I go back to the internet. So, if I had to see any of these things, for example, aluminum standard enclosures, various details are available here, and very quickly you can order, get these things as you want. You see here, this is one of the things which commonly people use. These are typically the plastic, thermoplastic enclosures, and any enclosure you want is available. So, I will stop here. I suggest you on your own try to locate all these various details I am talking about. One is various types of electrical items which are useful in your field. If you are into a conventional type of electronics where you have things like switches and displays, we are very familiar. The most tricky part of it is usually the rear panel where all the connectors are there. And of late we are very familiar with seeing very simple thing like the USB A and the USB mini and USB micro. Then C also has come. We are very familiar about those things. That part of it is the opening that is visible, but inside there is a huge shell and immediate hardware is there. And in the case of our electronic and audio, you have several other things including the ubiquitous 3.5 mm jack and all the way to XLR connectors. And anytime, next time you go to a music programmer, next time you go anywhere outside, you see that every audio source, everything by standard has changed over to XLR. And in XLR also some mild variations of things, the way they lock, including and just push, including bayonet, including what you call things with a screw threaded, all variations are available. And if you make all these details, it takes a lot of effort over the first time. For the next time onwards, it is very easy for you. You just have to call the library component, just like you do with your printed wiring board layout, put them everywhere on your front panel and the whole equipment, do necessary Boolean operations. So, you have an enclosure ready with all allowances and tolerances also taken care of. So, thank you. I will now see next time whether actually I can give you a practical slightly more complicated unit. Two variants, one of it is using a standard enclosure taken from the one of the catalogs, and another one from the what do you call various other options. A lot of this equipment which we have made in our own this thing I have kept on my hard disk. I will try to show one or two of them saying, now how do we create it in the new system which I am sure you will adopt as soon as we finish this. So, thank you, we will meet again.